Hello students, this is K. M. Prasad, Department of Computer Science, DBS IT, Kawal. Today we are in the subject R programming. In that R programming, we are in Unit 3. In that Unit 3, we are in the Chapter 1. This is the second video on Chapter 1. Here in this video, we are discussing graphical analysis, introduction to the graphical analysis. Now this is about already some of the concepts we discussed: box whisker plots, scatter plots, phase plots. Already we discussed about the box whisker plots and scatter plots. Now in this video or in this class, we are going to discuss phase plots, line charts, pie charts, Cleveland dot charts, bar charts, copy graphics to other applications. We are copying the graphics to the other applications. Now these are the concepts we are discussing in this video. Now coming to the first topic in this video, phase plots or multiple correlation plots. Phase plots. Now here the plot command here we are using to discuss the basic type of plots. Now coming to the phase plots, we are using the phase. Phase is the command which we are using to display or to perform or to show the phase plots. Now what is actually a phase plot means? Two columns of numerical data must be there. You have to specify the relationship between the two columns of the data. Now in that case we are using the phase plot command. Now it shows the syntax like pairs of. Here we are using the scientific notation like a tilt operator. In that tilt operator, tilt x plus y plus z, some set of parameters or some set of columns we are taking. By using some set of columns in a particular data, for that purpose we are drawing or we are going to perform all these phase plots. Now these are the plots which are especially used to show the relationship between two pairs of information. Now this is about the thing. Now coming to the line charts. Now what is actually the line chart here is in this previous one, the phase charts or normal charts, we are displaying some set of graphical symbols like circles or squares or etc. Now in this line chart, we are joining all the points. We are joining all the points and form a line. Here, so far we have looked at the plot command as a way to produce scatter plots. The scatter plots means some points are scattered in that area, that x and y area or two-dimensional area, either as a single pair of variables or a multiple pairs of plots, already single as well as multiple pairs. There may be many occasions when you have data that is time dependent. If you are using the time and then what in that time, how many kilometers we have traveled, how much work we have done, for that purpose we are taking time dependent variable and then another variable, that is the data is collected over a period of time. Some period of time that data is collected. You want to display these data as a scatter plot where the y-axis. Now we are specifying all the data is specified in the y-axis. Reflects the magnitude of the data. Now the y-axis contains the magnitude of data you recorded and the x-axis reflects the time. X-axis contains the time and y-axis contains the magnitude of data. How many kilometers and what time, how many types of things, etc. It would seem sensible to be able to join the data together with the lines in order to highlight the changes over time. For example, if you take the some 1 hour or something first hours or first session, second session, like this we are defining the time of the day, and that for that purpose in the 1 hour how much amount of reading is there, and second hour how much amount of reading is there, third hour how much amount of reading is there. For 24 hours we are recording some temperatures. Here in this one also we are recording some temperatures. Based on that one, those temperatures we are drawing the line charts. Here, in the normal chart, we are taking just the points only. But coming to the line charts, we are joining the points which are provided in that chart by using the lines. Now, these types of charts are called as the line charts. Line charts. Now, coming to the continuation of the line chart here, line charts using numerical data. Here, we are having different types of data. Now, one type of data is called as the numeric data. Now here, if the time variable you recorded is in the form of a numerical variable, you can use a regular plot command. Now, if you are taking the numerical data, just simply use the plot command. Type the instruction is used. Now, for example, what type of instruction we are using? It is typed by using this one. The following table lists the main options you can set using the type instruction. Here we are using some set of type instruction. Addition is added to the plot command. In that type instruction, we are specifying different types of plots or points, how points are there, what type of points we are taking, and how we are using the lines, what type of lines we are using, etc. Now here the table contains two columns, instruction and explanation. Instruction and explanation. Here the first one is type is equal to P. Here if you specify the type command like P, it can specify only points, not the lines. Now coming to the type is equal to B, points with the line segments between. Here we are specifying the points and line segments are also performed. Now coming to the type is equal to L, line segments alone with no points. Here we are specifying only line segments. The points are not given. The points are not specified. Just line segments are there. Points are not specified. Now coming to the type is equal to no gap between the line segments. Now, for example, if you are using only line segments, some gap is there between line segments. That gap is filled if you specify the type is equal to O. The gap is filled if you specify the type is equal to O. Now, without the gap, the line is drawing or the line is displayed. Now, coming to the type is equal to C. Small gaps are there in points. Now, if you want to specify the small gaps where the point is or etc. Now, for that purpose, we are using type is equal to C. Now, coming to the type is equal to N. Now, here if you specify the type is equal to N means nothing is plotted. The graph is produced setting x-axis scales, but data are not actually drawn in. If you are not just the graph, only simple graph or without any line, now you want to use the type is equal to N. Sometimes you are promoting that graph, but you are disabling the points, etc. Now we don't want to show to the others. For that purpose, we are taking the type is equal to N. Now this is about the line charts. If the line charts are having the numerical data. Now coming to the already the pie charts. Now the charts we are discussing here are available in the Excel itself, but Excel can take some set of values or some set of things, or it is limited. But coming to the R programming language, we can use different types of forms in the data. Data frames are there, matrices are there, and different types of vectors are there, etc. By using different types of data in variations, now we can easily show or you can easily present many number of graphics by using the R programming language. Now coming to the pie chart. Now this is just like a wheel of anything, just like a wheel. In that wheel, some portions specify. For example, one type of only one type of data, how much percentage we are specifying. Now, for example, if you are taking some sales in a week. Now, in first week, how much sales are there? In first day, how much sales are there? Second day, how much sales are there of a particular item? For example, if you are taking any item, how much sales are there? And then second day, how much sales are there in the same item? Now, coming to this pie chart, if you have data that represents how something is divided up between various categories, no, same data is divided up into the various categories. The pie chart is a common graphic chart to illustrate your data. Pie chart is very useful and common example. For example, if you might have data that shows sales for various items for a whole year. For example, if you are taking sales of the year, the pie chart enables you to show how each item contributed to total sales. Now, for example, you sold some set of items or 5 items or 6 items or something in a year. For example, some item 20% is sold, some item 30% is sold, some item 25% is sold or 21%. For total, it is 100%. Now, for that purpose, especially it is a very suitable chart, that is pie chart. Each item is represented by a slice of pie. Some slice of pie is used to represent every item. The bigger the slice, the bigger the contribution to the total sales, the bigger the slice. Now, what is the bigger slice? Our bigger slice can have maximum number of contribution of the total sales. In simple terms, the pie chart takes a series of data, determines the proportion of the each item toward the total. Now, the proportion of each item towards the total, and then represents these as different slices of the pie. Now, coming to the pie chart is commonly used to display proportional data. It is especially for the purpose of you are using what proportion the some set of item is specified like this. You can create pie charts using the pie command. The pie command, PIE, is the command which is used to create the pie charts. It's in the simplest form. We are taking a vector of numerical values. No, simply we are taking a vector of numerical values. By using a vector of numerical values, we can easily see the or specify the this. Now, coming to this one here, we are taking a data item. It contains some set of names, just like January, February, March or something, month names here we are taking to create a pie chart with the labels. Now, for these labels we are taking for the purpose of pie chart. Now, here pie is the command we are taking. Pie data 11 labels is equal to data. Now, here data is especially used or for the purpose of only labels purpose. Now, here we are specifying for the throughout the year 12 months are there. Now, for that 12 months we are taking the names. Now, here come to this produces a plot which is specified 7.19 in this chapter. Just you simply show the textbook which is already given to you. Now, that is 7.19. You can show this type of chart. Now, you can alter the direction and the starting point of the slices using the clockwise. Now, here we are using some instructions or additional instructions. Clockwise is equal to and init dot angle is equal to instructions. Here two instructions we are taking. By using these two instructions, we are specifying either clockwise direction or either anti-clockwise direction. By default, the slices are drawn counterclockwise. Normally, counterclockwise direction we are taking. Anti-clockwise, that is direction we are taking. Now here, so clockwise is equal to false. Normally the clockwise is equal to false. You can set this to true to produce the clockwise slices. Now if you specify this as a true, now we can make it as a clockwise. The starting angle is 3 o'clock, that is 0 degrees or something, it is 3 o'clock. By default, when you use the clockwise is equal to false, the starting angle is the 90 degrees, that is 12 o'clock. These are the two angles we are taking, whether for the clockwise as well as anti-clockwise. Now coming to the It is also very useful thing. Just like it is shown, just like a some dots we are specifying here. This is Cleveland dot charts. Now some dots, just like we are specifying some lines, horizontal lines or grid lines specifying for those grid lines. Now, for example, this is also it is used for the purpose of specifying some dots in the x and y direction area. An alternative to the pie chart. It is especially used for the alternative to the pie chart. Is a Cleveland dot plot. All data that might be presented as a pie chart could also be presented as by using bar chart or dot plots. You can create Cleveland dot plots using the dot chart command. Dot chart command is used to produce Cleveland dot charts. In the following example, we are taking some numerical vector of the character labels. Here data 8 and data 8 and data 11. Already in the previous one, the pie charts also we are taking the same thing, that is data 11 as well as data 8. Now data 11 contains some set of numerical values and the data 8 contains some set of characters, that means some set of strings or names. Now here we are taking example dot chart of data 11 comma labels is equal to data 8. Here also the resulting data plot, here also we are specifying the plot in the 7.23. Here it can specify same thing, x direction as well as y direction. Here we are specifying some set of dots we are specifying. Instead of slices are available in the pie chart, here we are using to specify the some set of dots. Now these are very important one. The dots are in the combination of all the things, what type of thing it is contributed, how much percentage it is contributed. These are specified by using the dots. Now coming to the bar charts. This is very useful one. Already the simple charts we are using, it can specify just like buildings or vertically or horizontally. We are specifying the what type of information or how much amount of data is there between. Here easily you can distinguish which type of thing is maximum and which one is smaller and etc. The bar chart is suitable for showing data that fall into discrete categories. The histogram is a form of bar chart. Now already we discussed about the histogram. It is also one of the form of the bar charts. In that example, each bar of the graph showed a number of items in a certain range of data values. Now here one bar specifies the range of the data values. Bar charts are widely used because they convey information in a readily understood fashion. By using this bar chart, we can easily show or easily specify, easily convey the readily available information. The information is ready to show something. They are also flexible and can show items in various groupings. Different types of groups are also we are taking, just like the stacked values or besides values we are taking, just like that. You just use the bar plot command to produce the bar charts. Bar plot is the command here we are using to produce the bar charts. The simplest plot can be made from a single vector of numeric values. Now here we are using simplest plots. It is the simplest plot which especially we are using for the numerical values. Here we are taking some rain data we are taking. Now coming to the example, bar plot of rain. Now it is also specified by using the figure 7.28. Now 7.28 is the figure number we are specifying. Now you can show this one or you can see in the textbook also. Here already some of the many number of graphics we discussed. Here comes to the how we are copying, how we are taking the produced graphs into different types of applications. What type of some set of applications we are taking from in PowerPoint presentations or in Word presentations or different types of application. How we are going to take all the things into the PowerPoint presentations. Now this is about the last topic in this chapter. Here copy graphics to other applications. Now already we created some set of graphs. Generally you need to transfer the graphs you have made to another application. You may need to make a report and want to include a graph in a word processor or presentation, etc. You may also want to save a graph as a file on disk. Now you can save it as a file on a disk for the later use. In this here, you discussed about how we are transferring or how we are taking or how we are saving, etc. Now the first one is use copy paste to copy graphic. Now simply already these are the very popular commands, copy and paste command. Just we are using copy and paste commands to transfer the graphics which are produced by using the R programming language into the Word or PowerPoint presentation. When you make a graph using R opens in a separate window. Now R programming language produces the graph in a separate window. If your graphics is not required to be of publication quality, it is not available in the specific quality, you can use copy to transfer the graphics to the clipboard and then use paste to place in the another program. Now you just simply use the copy and paste commands. This method works for all the operating systems. Now you can use this one in any operating system, and the image depends on the size of the graphics window and the resolution of your screen. Now you need to higher quality of the image. You simply need the graphics to be saved. Now you need to be higher quality or different format or different thing, etc. Now you have to be saved in a something, in a place. If you simply need a graphics to be saved as a file in the disk, the method you need to employ depends upon the operating system you are using. Now if you want to save this thing, it completely depends on the operating system you are using. No, you are using Windows 10 or Windows or Macintosh OS or Linux. Now what? It completely depends on this one. Now here the first one is save a graphics to disk. Now how we are saving the graphic to the disk? You can save a graphics window to a file in a variety of formats, including portable network graphics are there, giant photographic experts group are there, that is JPEG. Some tagged format is also available, some bitmap formats is, some PDF also available. You can save your graphics depends on the operating system you are using. In Windows and Macintosh, GUI has options to save graphics. If you are using Windows or that is Mac OS, some set of commands are there, especially for the purpose of GUI, graphical user interface commands. If you are using Linux, now you have to use some command prompt. For that command prompt, you have to remember some set of commands. By using only some set of commands, you are going to copy or save all the things. Here comes to the Windows. The Windows GUI allows you to save graphics in various file formats. Already we discussed about some of the formats like PNG, JPEG, TIFF, BMP, etc. PDF. Now using those formats, we can easily save. Once you have created your graphic, click the graphics window and select save as. Now already you created this one. You click the select as, save as or something from the file menu. You have several options to choose from the list. Now you have different types of operations. Those are specified in the 7.40. Now using those options, you can save all your information. Now coming to this one, other applications, how we are saving this one to them. Now here you can also use commands typed from the keyboard to save the graphics files to disk. Now commands we are typing from the keyboard, you are also type some set of commands. By using those commands, we can save the created graphics to the other applications. We go to the several ways. The simplest is via dev.device copy. Device, that means dev.copy is the command which is especially used to copy the information or the graphics which is available in the R environment. Other options. This command copies the contents of the graphics window to a file. Now it is copied to the file. To designate the type of the file and the file name, here you have to specify what type of file we are taking and then what is everything. To finish the process, you type the div off. Now, if you are going to stop this one or complete this process, now you can use the dev.off command. Now, this command will stop the copying process or something. In the following example, just you take this one. Now, dev.copy PNG format. Here we are taking PNG format. Now, this is a very, very useful format for networks. Now, file is equal to our graphics test.ep. Some file we are taking. For that file, this we are taking all the information. Now coming to the PNG something. Now dev.off is the command which is used to stop this process. Now this is about the lesson 2 of the graphics. What type of graphics we are producing and what type of things we are taking, etc. by using the R programming language.